Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class, we are going to continue the chapter chemical reactions and equations. Just could you recall the concepts what we learned in yesterday's class? Yes, what is that? Yeah, you are right, it's about different types of chemical reactions. Then recall them one by one. What is that first one? It is combination reaction. Recall its definition as well. The type of chemical reaction in which two or more substances combine chemically to form single product, nothing but single substance, right? This is called chemical reaction. Then how we expressed this reaction in general? Yes, it is A plus B gives rise to AB. Give an example for this. When magnesium reacts with oxygen, produces a single compound, that is magnesium oxide. So 2Mg, here 2MgO. Next, second one. The second type of chemical reaction is, it is decomposition reaction. Is it not? Then tell the definition of it. The type of chemical reaction in which a substance gets split up into two or more substances. This is known as decomposition reaction. And what is its general form? We can write it as AB gives rise to A plus B. And give one simple example, and which is also most important. What is that? It is when lead nitrate PbNO3 twice undergoes decomposition reaction, then it produces compounds like PbO plus NO2 plus O2, right? Next, third type of chemical reaction is, it is displacement reaction. It is a type of chemical reaction in which an element present in the compound is displaced by another element which is more reactive. Is it not? It is called displacement reaction. Then we can write this as AB plus C gives rise to CB plus A. A gets separated because C is more reactive than A. Then one example, most familiar to us, it is copper sulfate solution. In that, when you go for placing iron, it produces a compound called iron sulfate plus copper gets separated. Here it is because iron is more reactive than copper. And in this reaction only, we have come to know that the arrangement of metals in the decreasing order of their reactivity. The arrangement of metals in the decreasing order of their reactivity is known as reactivity series. Do you remember that? The code what I had given yesterday? Yes, it is Kanaka Mazi PCR, right? And according to that, you can go for listing the metals as first. It is potassium, next sodium, see that. Then calcium, magnesium, zinc, and it comes, and at last we will get silver as well as gold. Please learn that one. Next, what is the fourth type of chemical reaction? It is double displacement reaction. Is it not? Fourth one, double displacement reaction. According to this, the type of chemical reaction in which the radicals or the ions present in the two compounds mutually exchange to form two new compounds. Is it not? This is double displacement reaction. And how do you write its general form? It is AB plus CD gives rise to, we know that this is AD plus, and this is CB. And give a simple example for this. Again, you go for taking one PbNO3 twice. Aqueous solution of lead nitrate reacts with aqueous solution of potassium iodide to form PbI2. This is yellow color precipitate plus KNO3. Got it? Dear students, I have told you so many times, whatever the chemical equation can be written, you have to write that as a balanced one. Remember that one. And fifth one, it is redox reaction. According to this, the type of chemical reaction in which the oxidation and reduction take place simultaneously. Is it not? Then what is oxidation? That is the addition of oxygen to a substance or removal of hydrogen from a substance in a chemical reaction is called oxidation. Then what about reduction? The addition of hydrogen to a substance or removal of oxygen from a substance in a chemical reaction is called reduction. There are some chemical reaction where or in which both the types will take place together. That is called redox reaction. Yesterday we had taken one simple example, that is CuO, copper oxide, reacts with hydrogen to form copper plus H2O. Here oxygen is present in this, so oxygen is removed from copper oxide and it gets reduced to copper. Here, what do you call the removal of oxygen? It is reduction. And this removed oxygen is added to hydrogen and it gets oxidizes to water. Hydrogen gets oxidizes to water. So this is addition of oxygen and we call it as oxidation. Observe, in this chemical reaction, both the types are present. That is why it is called redox reaction. Clear? So this much we had discussed in the last class. Now, dear students, in today's class, we are going to get the detailed information about each type of chemical reaction. Let's move on to one by one. In that, first one is, it is combination reaction. So, I am going to explain some of the experiments, some of the activities related to each of these types of chemical reactions. Let's move on to some of the important experiments. Important experiments or activities. And these are related to different types of chemical reactions. In that, I'll go for taking the first experiment. Experiment number 1. This is related to combination reaction. So, I have already given you one example for combination. When magnesium reacts with oxygen, gives rise to magnesium oxide. Then how can we show this is a combination reaction? That we are going to write. The question will be given in this way. Explain with a neat level diagram to show burning of magnesium is a combination reaction. Let me go for writing the question. Observe, this is the experiment. To show that burning of magnesium is a combination reaction. This is the aim of the experiment. Dear students, I have already told you the question. The question is, explain the experiment with a neat level diagram to show the burning of magnesium is a combination reaction. Observe it. Here we need some of the materials and all these materials are arranged in this way that has been shown in the figure. So we have the magnesium ribbon, then fire tongs, and this is Bunsen burner, and it is kept on the experiment table. Clear up? Then let's move on to the procedure. First you have to take a magnesium ribbon, a strip of magnesium ribbon, and wipe it with sandpaper. We know the reason for this. When the magnesium ribbon is exposed to the atmosphere, it slowly reacts with carbon dioxide and forms a thin layer of magnesium carbonate. And by rubbing it with sandpaper, we can remove magnesium carbonate so that it can be burnt easily. See, take a strip of magnesium ribbon, that is rubbed magnesium ribbon, and fix it that in the fire tongs. Then keep that strip of magnesium in the Bunsen burner flame. Then wait for a while. What happens here? Here it starts burning with a dazzling white flame. Then it produces a compound. You can a white color compound or white color residue. You can collect this in watch glass, and this is called magnesium oxide. Clear? Then how this will be an example for combination reaction? See that when the magnesium ribbon is burnt in the air, it reacts with oxygen and produces only the single compound, that is called magnesium oxide. Two reactants combine to form single product. That is why it is a combination reaction. Clear? Yes. Please go for writing this, drawing this one. Here I have written the procedure. Just go through, and it has been written point wise clearly. Please, you have to copy like this only. Okay. So the first point is, take a strip of magnesium ribbon and rub it with sandpaper. You know the reason, to remove the unwanted impurity. What is that? Magnesium carbonate. Then after that, fix the strip in the fire tongs. Then place that strip in the Bunsen burner flame. Then what will be your observation? Magnesium ribbon burns with white dazzling flame, with producing a compound. What is that? Magnesium oxide. So that is the observation, and equation can be written like this. Mg plus O2 gives rise to MgO. Then we have balanced it. 2Mg plus O2 gives rise to 2MgO. And to make it as more informative, we have mentioned their physical states as well. Magnesium is a solid, oxygen is gas. Whatever the magnesium oxide is formed, it is a solid. It will be in powdered form. Its color is white. And in this reaction, you have come to know that two reactants combine to form single product. That is why burning of magnesium is a combination reaction. Got it? Please go for writing as it is. Copy this. Let's move on to another experiment. This is also very important with respect to combination reaction. Observe it. To show the reaction between calcium oxide and water is a combination reaction. We are familiar with both the compounds. Calcium oxide, what is its molecular formula? Yes, you are right. It is CaO. Then water, it is H2O. Observe it. Now, first let us come to know what are the materials required for conducting an experiment with respect to this. I'll go for drawing the figure. Observe it. Here we have taken some of the materials. They are, one is hard glass beaker. Then a test tube has been taken. Next, the crystals of calcium oxide, which is solid. Then we need water, because we are going to know the reaction between calcium oxide and water. Got it? Observe it. First we have taken the crystals of calcium oxide in a hard glass beaker. Then after that, just go for adding water to the beaker along the side of the beaker. Then immediately you can observe that this calcium oxide reacts vigorously with water. You can also see the small sparks and also bit crackling sound. Got it? So that is the reaction we can observe. Then what are the reactants which undergo? One is calcium oxide and another one is water. And these two react with each other and produce a compound. And we call this compound as calcium hydroxide. It is calcium hydroxide. And we can write like this, CaOH twice. Got it? So calcium hydroxide, it is solid. Water, it is liquid. And this is aqueous. Observe, here also two reactants combine chemically to form single product. That is why it is called a combination reaction. Hope that you have understood. Then after that, you just go for touching the beaker. How do you feel? You feel hot. Do you know why? Because of the vigorous reaction between calcium and water, calcium oxide and water, it produces the heat energy. Got it? As heat is produced during the chemical reaction, this is also an example for exothermic chemical reaction or exothermic reaction. EXO, exo. Exo means giving out. Exothermic. Thermo means heat. So heat is given out. Heat is produced during the chemical reaction. That is why it is called exothermic reaction. Once I repeat, the chemical reaction in which heat is given out is called exothermic chemical reaction. Then whatever the compound we have, that is calcium hydroxide, it is also known as, it is slaked lime. Then what we say about calcium oxide? This is quicklime. Got it? And even you are also familiar with one of the use of slaked lime, nothing but calcium hydroxide. It is to be used for whitewashing. Is it not? And when this calcium hydroxide is applied to the wall, after 2 to 3 days, wall get shiny appearance. Do you know the reason for this? Yes, let me tell you that. Here, when calcium hydroxide is applied to the wall, it slowly reacts with carbon dioxide present in the atmosphere, that is CO2. And after 2 to 3 days, wall get shiny appearance. It is because of a thin layer which is formed on the wall. It is calcium carbonate, CaCO3, and water get evaporated. Clear? To remember, when calcium hydroxide is applied to the wall, after 2 to 3 days, wall get shiny appearance. It is because calcium hydroxide reacts slowly with carbon dioxide present in the atmosphere and form a thin layer of calcium carbonate which has shiny appearance. That is why wall get shiny appearance. Clear? So particularly in this chemical reaction, we have come to know two more important things. One is exothermic and second one is why the wall gets shiny appearance after 2 to 3 days of applying calcium hydroxide to the wall. Clear? Yes. Now I will go for writing the procedure. Please copy. You just draw the figure with leavening. Got it? Yes. Dear students, observe. Here I have written the procedure. First, take a small amount of calcium oxide in a hard glass beaker. Then add water to it slowly along the wall of the beaker using the test tube. Then it reacts vigorously with water and forms a compound called calcium carbonate. With water to form calcium hydroxide. Calcium hydroxide. That is CaOH twice. And we can write here. Calcium oxide reacts with water to form calcium hydroxide. And this is solid, water is liquid, calcium hydroxide is aqueous. In this reaction, two reactants combine chemically to form a single product. That is why it is a combination reaction. Clear? Next, there are some important points we discussed. First point, during this reaction, a boiling sound as well as crackling sound is sound heard. Next, another one, when you have to test the beaker carefully. When the beaker is touched, we feel very hot. That means during the reaction, heat is given out. Next, another important point. Whatever the calcium hydroxide is there, when it is applied to the wall, it gets a shiny appearance after 2 to 3 days of whitewashing. Reason? When it is applied to the wall, it reacts slowly with the carbon dioxide in the atmosphere and forms a thin layer of shiny compound called calcium carbonate. Followed? Yes, please go for copying from that procedure from there to here. Dear students, now I am going to take some simple examples for the chemical reactions. Keep observing. Just we discussed one chemical reaction, that is calcium oxide reacts with water to form calcium hydroxide. And you have also come to know that when the beaker is touched, we feel hot. That means heat energy is released. Is it not? Like similarly, when magnesium reacts with oxygen, on burning magnesium with the oxygen, burning in the flame, Bunsen flame, then it reacts with oxygen and produces magnesium oxide with white dazzling flame. That is also heat energy. Right? Similarly, assume that there is a material whose main component is carbon. It reacts with oxygen, then consider it as a sphere. When it reacts with oxygen, it produces carbon dioxide. Then when the fuel is burning, again you can see the heat energy is released. Is it not? Next, one more. Let us go for taking LPG, liquefied petroleum gas. What is the main component of it? It is, you are right, butane. We have learnt in previous classes only. Butane, what is its molecular formula? C4H10. When this butane is burnt, it reacts with oxygen to produce carbon dioxide as well as water vapors. At the same time, we can also see the flame, that is nothing but heat energy. Is it not? In all these chemical reactions, you can come to know that heat energy is released. Therefore, we call these reactions as exothermic reaction. Then what is exothermic reaction? The chemical reaction in which heat is released along with the products. Followed? Yes. Now let me write the definition of it. Yes. This is the definition and these are the examples. Now I'll go for taking one more simple example. Before that, just I'll ask you a simple question. Then could you tell how do we get energy? Yes, energy comes from the food. Then how this food is responsible for producing energy in our body? Yeah, let me explain that. Whatever the food item we go for eating, they contain many factors like vitamins will be there, carbohydrates will be there, proteins will be there, lipids will be there. Is it not? So when the food is taken, it is broken down. Nothing but carbohydrates are broken down and they are converted into glucose. And this glucose will react with oxygen present in our cells of our body, and it produces what? The energy. And I can show you the chemical reaction taking place in our body like this. It is glucose C6H12O6. How it is obtained? It is obtained from the food. In the factors that are present in the food, they are broken down and are converted into glucose. And this glucose will react with the oxygen present in the cells of our body and produces. Can you tell the compounds that are produced? Carbon dioxide, water and energy. So that is why in our body some amount of heat is always present. If no heat is present in our body, then we can decide that so the person is no more. Got it? So this process is known as respiration. And can we say respiration is an example for exothermic? Yes, because here heat energy is given out. Got it? And now please write the definition and these example. And then after that I'll go for giving information about respiration. Here I have written about respiration. Respiration is an exothermic reaction, right? So that explanation has been written. During digestion, food is broken down into glucose, and this glucose reacts with oxygen in the cells of our body and gives out the energy in the form of heat. Therefore, respiration and digestion is an exothermic reaction. And the chemical equation has been written with respect to this. Glucose C6H12O6 plus O2 oxygen gives rise to carbon dioxide plus water plus energy. Then here we have written 2 more points. You can go through them. Please copy from here to here quickly. Dear students, now we are moving to the third experiment, that is to show heating of ferrous sulfate is dash reaction. What type of reaction it is? Purposefully I have not written. Just by observing the experiment you can decide what type of chemical reaction it is. Yes, it needs some of the material to conduct. They are, one is some crystals of ferrous sulfate. What is its molecular formula? Yes, it is FeSO4. Could you tell what is its color? Right, the color is, it is pale green. And the actual formula is FeSO4 7H2O, means some number of water molecules will be present. Got it? That is 7 molecules of water present in 1 formula unit mass of ferrous sulfate or iron sulfate. That is why it is called hydrated salt. And because of the water present in the salt, its color is pale green. Now let us come to know what happens when it is heated. For heating purpose we need Bunsen burner, and also we need test tube as well as test tube holder. After knowing all these materials, how to arrange them, let me show that with a diagram. I will draw it. Dear students, observe. First we have taken a boiling tube. Boiling tube is nothing but test tube. Particularly we are using the words boiling tube because this is the hard glass test tube used for heating. And in that we have taken some crystals of iron sulfate. We know that its color is pale green. Then fix the test tube to the test tube holder. Then and start heating that in the Bunsen burner flame. And please do remember, when you are boiling, the mouth of the test tube should be away from your face. Got it? Please do remember that one. And when you keep on observing, you just keep on heating that, then after that you will come to know in that whatever the crystal is present, green color crystals of iron sulfate is present, it will start turning to white. Do you know the reason? Because the water of crystallization is removed. Nothing but the amount of water present in it get removed. It will turn to white. Then after that, here, then when you keep observe, when you continue to provide the heat, then this white color crystals will turn to brown. Got it? And we call this brown color residue as ferric oxide. Followed? Then you can also observe the fumes will be coming out, and these fumes are sulfur dioxide. Clear? Then after that, when you go for inhaling the smell of it, when you inhale the smell of it, you feel coughing. Got it? And because one more gas will be releasing, that is transparent, and we call it as sulfur trioxide. Understood? Here, alright, FeSO4 crystals, when they are heated, then it gets split up into iron oxide Fe2O3 plus sulfur dioxide SO2 and sulfur trioxide. Now see that here is a single reactant is there. It gets split up into 3 products. Then what type of chemical reaction it is? Yes, you are right. It is called decomposition reaction. Decomposition reaction. Now this is the aim, to show the heating of ferrous sulfate is a decomposition reaction. Followed? Yes. Please go for completing this, and after that you go for drawing also. Yes. Now you can move on to the procedure. Observe. Very simple way. Take about 2 grams of ferrous sulfate crystals. Few amount of ferrous sulfate crystals in dry boiling tube, and heat the boiling tube in the Bunsen burner flame. Then you will notice that the green color of ferrous sulfate is removed. It is because of the removal of water of crystallization. Then it will turn white. After that it turns brown. That is nothing but ferric oxide. Then along with that, sulfur dioxide, which is pungent, and sulfur trioxide, these gases are also released. And the equation, chemical equation has been written. FeSO4 gives rise to Fe2O3 plus SO2 plus SO3. Observe, in this chemical reaction we can come to know that one substance gets split up into 3 substances. That is more than one substances. That is why it is called decomposition reaction. Clear? Yes. Please go for copying from procedure 2 here. Dear students, now we are moving to one more important. Observe. To show heating of lead nitrate is a decomposition reaction. See, these are the materials required. Test tube holder, test tube, lead nitrate, Bunsen burner, then experiment table. Then first you have to take some crystals of lead nitrate in the test tube. What is the color of the lead nitrate? It is white. White crystals of lead nitrate is taken in the test tube. Then fix the test tube to the test tube holder. Then hold it and introduce that in the lead nitrate. That means you start heating the test tube in the Bunsen burner flame. Then you know what we will observe. You just heat it for a while. Then this white color of crystals of lead nitrate will start turning to yellow, light yellow. Got it? Then after that you will also notice that the brown color fumes start coming out. Clear? Then you may be thinking that what is that yellow color residue? It is lead oxide, lead PbO, and the brown color fumes, these are nitrogen fumes, nitrogen dioxide fumes. Then after that you just go for taking a lighted incense stick and introduce that into the test tube. Then it will start burning brightly. It is due to the presence of oxygen. Clear? So from this experiment we can come to know that when lead nitrate PbNO3 twice is heated, it gets decomposes into yellow color residue, that is called lead oxide. Then brown color fumes, nothing but nitrogen oxide. Then brightness, increasing the brightness of the incense stick, it is because of the presence of oxygen. Here also one compound gets split up into 3 compounds. One substance decomposes to 3 substances. That is why we can say that it is a decomposition reaction. Did you understand? Now, please do remember the products that are formed when lead nitrate is heated. What are those? One is lead oxide, second one is nitrogen dioxide, third one is oxygen. And what is the color of lead oxide? It is yellow. Then how can you identify the nitrogen dioxide gases or fumes are coming out? It is the brown color fumes will come out during the chemical reaction. Based on that, you can say they are nitrogen dioxide. Next one, the presence of oxygen. Even when you bring a lighted matchstick near the mouth of the test tube, then it start burning brightly. That is also the indication of the presence of oxygen. Understood? Okay, now let me go for writing the procedure. Please go for copying this experiment number 4 and draw the figure. Observe this procedure. First, take about few crystals of lead nitrate in the test tube and hold it in the test tube holder. Then heat the test tube in the Bunsen burner flame. Then you can observe that the emission of brown fumes and yellowish residue is formed. Then when the lighted incense stick is introduced into the test tube, then it burns rapidly, nothing but it burns brightly, which shows that the presence of oxygen. And to represent this chemical reaction, we have written the equation. PbNO3 twice gives rise to PbO plus NO2 plus O2. Here in this reaction, one substance gets split up into 3 more substances. Therefore, it is a decomposition reaction. Hope that you have understood. You have already copied that. Now you are going to write the procedure from here to here. Yes, copy this. Dear students, now we are moving to experiment number 5. Observe that. To show that electrolysis of water is a decomposition reaction. This concept is very familiar to you. Electrolysis of water. What is that? Just to recall it. When electricity is passed through the water, it gets decomposes to hydrogen and oxygen, and this process is known as electrolysis of water. So now we have to show that it is a decomposition reaction. Hence we need some of the materials. The materials required are, one is we need a bottle having no bottom. Got it? Next we need the 2-hole rubber cork. And third one, we need graphite rods which are to be used as electrodes. Then 6-volt battery, wire, then iron stand. Now let me show you how to draw the diagram which represents the arrangement of these materials. And do remember, this experiment is very important in the examination point of view. Just keep observing the way I am going to draw. Here we are going to take a glass bottle having no bottom. Observe. Very simple way of drawing. This is the glass bottle. Then, and this is opened. Here we will go for taking the rubber cork, 2-hole rubber cork. It is to be fixed in the mouth of the glass bottle. Next, you go for taking 2 graphite rods, and these graphite rods are to be inserted in the 2 holes. Look here. Then these are the graphite rods. I am going to shade it. And these graphite rods are to be connected to the terminals of a battery. Let me draw that. Observe it. This is Y, and one end of the wire is connected to one graphite rod and other end is connected to positive terminal of a battery. And we will go for taking one more wire. One end of it is connected to another electrode and other end is connected to negative terminal of a battery along with the switch. Clear up? And do remember, this arrangement is going to be fixed to the iron stand. Here I am going to draw the iron stand. Observe. This is iron stand. For that we have fixed this arrangement. Next, here the support I am going to draw in this way. Please keep observing. Yes, this is the arrangement. Okay. Next, let's move on to procedure. Observe. Here, once I tell you that arrangement, take a glass bottle having no bottom and close its mouth with 2-holed rubber cap and take 2 electrodes, nothing but graphite rods, and inserted them into the holes. Clear up? Next, then connect the electrodes to the terminals of a battery. One is to be connected to positive and another one is to be connected to negative terminal. The electrode which is connected to positive terminal, it is called anode. Please do remember. And the electrode which is connected to negative terminal is called cathode. Clear up? Then after this whole arrangement is to be fixed to the iron stand. Next, take some amount of water. Now we are going to take distilled water into the bottle such that these graphite rods should be immersed in the water. So the level of water should be like this. Clear? And another thing is, to make it as conducting, we will go for adding a few drops of dilute HCl or H2SO4, hydrochloric acid or sulfuric acid. Then it becomes acidified water. Next, take 2 test tubes and fill them with water and insert them such that to cover these 2 electrodes. So these are the 2 test tubes. Observe them. Next, now you can notice that here after this arrangement, then you can go for closing the circuit. Now circuit is completed, then the current start flowing from positive terminal to negative terminal of the battery. Immediately you will notice the formation of the bubbles on the electrodes. That indicates these bubbles are filled with the gases. Then what are those gases? Let us come to know that later. And you can also notice that these bubbles will start filling these test tube. And observe. You can notice that the level of volume of the gas collected in both the test tube. You call this as A and this as B, right? You can notice that the amount of gas collected in test tube A is half of the amount of gas collected in B, or the volume of gas collected in B is double that of A, right? Then just keep you just continue to flow the current in this circuit, then such that both the test tubes should be completely filled with the gases. Then after that, remove these test tubes using the tongs, 5 tongs. Then I call it as A and this is B. Then bring a lighted mastic near the mouth of the test tube. Then what will be our observation in case of A? Then it start burning brightly. That indicates it is due to the presence of oxygen, right? And similarly, bring a lighted mastic near the mouth of the test tube B. Then you will hear the pop sound that indicates the presence of hydrogen. Clear? So from this experiment, we can come to know that when electricity is passed through acidified water, then it gets decomposes into hydrogen and oxygen. And this hydrogen and oxygen will be in the ratio of 2:1 because the amount of gas collected in test tube B is hydrogen. It is double than that of gas collected in A, that is oxygen. Hope that you have understood. Now you will go for drawing this, and before that, once we will move on to this, let us go for leveling the parts first. What it is? It is a glass bottle with no bottom. Next, this is acidified water. Then what are these? This is a test tube. Even this is also. And what do you say about these two? These two are graphite rods, nothing but electrodes. And this one, it is a 2-hole rubber cork. And this is the wire. It is switch and is battery. So you may call it a 6-volt battery. What about this? This is iron strand. Followed? Yes, go for drawing and level the parts yourself. Now, you have already drawn and labeled, you just go for checking it. Now, I will go for writing the procedure of this. Here I have written the procedure related to electrolysis of water. Go through this. Once, take a glass bottle without bottom and close its mouth with a 2-hole rubber cork. Then introduce carbon rods, they are nothing but electrodes in these holes, and connect them to a battery along with the switch. And do remember, here the electrode which is connected to positive terminal is called anode, and the electrode which is connected to negative terminal is called cathode. Then fill the bottle with water such that the electrodes are immersed completely. Then add few drops of dilute HCl to it to make it as more conductor or more conducting. Then take 2 test tubes filled with water and immerse them over the 2 carbon rods. Next, switch on and leave the apparatus undisturbed for some time. Then we can observe that the formation of bubbles at the electrodes, which indicates they are filled with the gases. And the volume of gas collected in the test tube is different from 1 to 1. There we have shown that. Once the test tubes are filled with the gas, filled with the respective gases, then remove them using the 5 tongs carefully. Then test them with a lighted mastic. When you bring a lighted mastic nearby the mouth of the test tube which is connected to positive terminal, here it burns rapidly or brightly, which indicates oxygen gas is collected in test tube A. Then similarly, when you bring a lighted mastic near the mouth of the test tube which is connected to negative terminal, then you will hear the pop sound which indicates the hydrogen gas is released. Followed, then we can, after this, we can write the chemical reaction as H2O gives rise to here electricity plus H2 plus O2. Here 2H2O, here 2H2 plus O2. this is liquid, this is gas, and even this is also gas. In this reaction, you can come to know that one compound gets split up into two compounds. One substance decomposes to two substances. Therefore, it is decomposition reaction. So, right up to here. So, write the procedure from here to here. After that, copy this. Hope that you have written up to here. Then from here, in this reaction, that is in the above reaction, H2O decomposes to hydrogen and oxygen. Therefore, electrolysis of water is a decomposition reaction. And dear students, you know that what is electrolysis? What it is? And we also know that when electricity is passed through acidified water, then it decomposes to hydrogen and oxygen. And this is known as electrolysis. And the chemical reaction for this is one. 2H2O gives rise to 2H2 plus O2. And we have also come to know one more thing, that the gas collected in the test tube will be in the ratio of 2:1. That is amount of gas collected in the test tube which is connected to negative terminal is double that of the gas collected in the test tube connected to positive terminal. Clear? So here I'll write hydrogen gas is to oxygen gas. These will be collected in the ratio 2:1. Please do it. Next, another one. What do you call the electrode which is connected to positive terminal? It is anode. Here I'll write an electrode connected to positive terminal is called, what it is called is anode. Followed, and the negative terminal is called cathode. Got it? But whereas in case of ions, positive ions are cations, negative ions are anions. But here it is reverse in case of electrode. Electrode which is connected to positive terminal is anode and negative terminal is cathode. This is a bit information about electrolysis of water. And please copy from here to here. After that we have one more experiment. See, this is experiment number 6. Go through this. Aim of the experiment is to show that silver chloride decomposes in the presence of sunlight. Got it? How the question can be asked? Like this. Explain with a neat level diagram to show silver chloride decomposes in the presence of sunlight. See, these are the materials required. Here I have taken china dish. In that silver chloride is taken. Then do you know what is the color of the silver chloride? Yes, you are right. This is white. When this silver chloride is exposed to the sunlight, then it undergoes decomposition. How can we come to know that? Here it will turn to grey color. So here AgCl in the presence of sunlight, it decomposes to silver and chlorine. Followed. Now here you can observe that there is a single compound. It gets split up into two compounds. That is why it is an example for combination reaction. Decomposition reaction. Decomposition. Composition is there. Decomposition. Splitting. Followed. Yes, please go for writing this, then I'll go for writing the procedure. Now I have written the procedure. Please go through that. Take about 2 gram of AgCl in a china dish. Then place the china dish containing AgCl in sunlight for some time. Then you can notice that white color of AgCl turns grey. That indicates silver metal is formed. And also you can experience the smell of chlorine. It indicates chlorine gas is also released. That can be written like this. 2 AgCl gives rise to Ag plus Cl2. In this reaction, one compound gets split up into 2 compounds. That's why it is a decomposition reaction. Clear? So all 6 experiments are over with respect to first 2 types of chemical reactions. Now, observe, I am going to take these examples only. In the first one, PbNO3 twice. When PbNO3 twice, that is lead nitrate, is heated, what happened? Lead oxide is formed, nitrogen dioxide gas is released. This is yellow color and this is brown color. Then oxygen gas is also released. Right? Next, another one. When electricity is passed through acidified water, it gets decomposes to hydrogen and oxygen. And one more thing, just we have come to know that AgCl, even it is also applicable for AgBr, silver bromide. Here silver chloride, when it is exposed in the presence of sunlight, then it gets split up into silver and chlorine. Dear students, when you observe all these experiments, you can come to know that decomposition is carried out by the presence of some of the factors. What are those? One is heat, second one is electricity, and third one is sunlight. Followed? Here, the first one is decomposition reaction is carried out by supplying heat. Second decomposition reaction is carried out by passing electricity. And third decomposition reaction is carried out in the presence of sunlight. So based on the conditions under which the decomposition reaction is carried out, it can be classified into some types. So let me go for telling those one by one afterwards. And another important point to be considered in this case, whatever the energy you can, the form of energy by which the decomposition reaction carried out. Observe here. First one, lead nitrate by supplying heat, that means it absorbs the heat to undergo decomposition, and then it produces lead oxide and nitrogen dioxide as well as oxygen. Whereas for H2O, energy is in the form of electricity, that is electrical energy. It uses the electrical energy and gets split up into hydrogen and oxygen. Silver chloride, it uses the energy present in the sun and split up into silver and chlorine. Did you understand? Here, in all these chemical reactions are carried out by absorbing the heat to produce the compounds. Then what do you call that reaction? The reaction in which energy is absorbed to form the products is called endothermic reaction. Endo means what? It is inside, within. Then thermo, it is heat. So heat is absorbed. That is why, and these are also the examples for endothermic, particularly when the heat is used. So regarding the endothermic reaction as well as the type of decomposition reaction, we can get more information about these in the next class. Before that, just I'll give you a bit information about it. The decomposition reaction which is carried out by supplying heat is called thermal decomposition. Second one, the decomposition reaction which is carried out by passing electricity is called electrolysis, and the decomposition reaction which is carried out in the presence of sunlight is called photolysis or photochemical reaction. Clear? So one is thermal decomposition, second one is electrolysis, third one is photolysis. Along with that, we have come to know one more, that is endothermic reactions. We shall get detailed information about these four in the next class, that is on Monday. Okay, dear students, before concluding the class, I would like to remind you one thing, that whatever the syllabus we have covered, and particularly the experiments, all are very important in the examination point of view. Please work out them today itself and learn them perfectly and get ready for tomorrow's test. Okay, with this, let us stop the class. Thank you very much.